So tonight we're going to move on to the next section of the polynomial unit, which is factoring polynomials. So in your notebooks, you guys are going to take notes today on factoring. And I apologize if my voice goes in and out. I am getting really sick, so I might lose it at some points. Factoring polynomials. So a lot of the strategies that you've already learned how to do when you learn how to factor in the quadratic unit, you're going to apply today during the notes and throughout the rest of this week. So previously with quadratics, we learned how to identify and factor out a GCF. That's one strategy of factoring. You also learned how to guess and check when factoring trinomials. And if the trinomials had lots of factor pairs, you also learned how to use the grouping method to factor. And then there were two shortcut methods of factoring from quadratics, difference of two squares and the perfect squared trinomial. So those are all going to come into play in the lessons over the next few days. And the reason why I'm having you guys to watch the video on this lesson is there's not going to really be too much new. So I felt like it was something that you'd be able to follow along and do at home rather than me just directly teach you in class and waste that time. So we're going to start off by factoring polynomials that have 4 terms. Okay, so we're going to factor with 4 terms. These are 4 terms, and when we have 4 terms, the strategy for factoring will be the grouping method. So we'll do 4 of these. So the first one is going to be x cubed minus 2x squared minus 9x plus 18. Now, when you learned the grouping method from Miss M, you did the grouping method on trinomials, meaning 3 terms. But you took that middle B term and you split it apart to create 4 terms. And then you split the problem in half. Well, this already has 4 terms. So we're able to skip that, making that X chart to find factors of A and C. We can go right to just splitting the problem in half and identifying the GCF on each side. So on the left side of this cubic, we're going to factor out a GCF of x squared, leaving us with x minus 2 once you do that. On the other side, you look for the GCF of negative 9x and positive 18. And whenever that leading term on the right-hand side is negative, you're going to factor out a negative. So we will factor out a negative 9, leaving us with x minus 2. The grouping method only works when both terms have a common factor. So this left term and this right term both have a common factor of x minus 2, which I will factor out, leaving behind an x squared minus 9. So this example right here is going to demonstrate something that will happen quite often. So you got to be on the lookout. You're going to probably think you're done at this point, but you're not. These little guys here are going to pop up in a lot of our examples. So before you say you're done with an example, always check to see if you still have one of your shortcut ways of strategy, a difference of 2 squares, and we'll learn about some other shortcuts tomorrow. So that can go further. I'm going to bring down my x minus 2, and the difference of 2 squares will become x plus 3 and x minus 3. And that's an example of doing the grouping method with 4 terms. Okay, so I'm going to put another one up here. So x squared y squared minus 3x squared minus 4y squared plus 12. So even though it has x's and y's in it, we can still go through and do this process. So I'm going to go ahead and split it in half and go through and factor out our GCF on each side. So the left side, we're going to factor out an x squared, leaving us with y squared minus 3. On the right side, a negative 4, leaving us with y squared minus 3. Both terms have a factor of x squared minus 3. And if we remove that factor from both terms, we will be left with x squared minus 4. Double check those 2 factors right there. One of them can go further, and it will be the x squared minus 4, because 4 is a perfect square, 3 is not, so the y squared minus 3 is going to stay as is. And then the x squared minus 4 will become x plus 2 and x minus 2. Okay. Next one I'm going to put up here, I'm going to have you guys try on your own. So when I'm done writing it, I'm going to ask you guys to pause the video, give it a shot, and then look through my work. So at this point, go ahead and pause, work through it yourself, and then unpause to check your answer. Splitting it in half, and GCF of x, that's going to leave me with xy plus 1. And over on the other side, it's a GCF of 2. The leading term is positive, so I'm going to factor out a positive 2. You do need that plus sign there to separate the terms on the left from the terms on the right. So you do need that sign. And that'll leave me with the xy plus 1. Both terms factor out an xy plus 1, leaving you with x plus 2. And that's as far as that one can go. Just keep in mind when you're doing the grouping method and you're trying to identify a GCF, if there isn't one, you still would factor out a 1 or a negative 1, depending on the leading coefficient. One last grouping method. So 240 m squared n plus 384 m squared minus 30 bmn minus 48 bm. So lots of variables going on here. We're going to start off looking at both terms, actually all the terms, and this particular problem would be an example where there's a GCF present before anything else. That should technically always be the first thing you're looking for. Is there a greatest common factor amongst every single one of my terms? And in this case, there will be. So I'm going to give you a second to see if you can figure out what number goes into all 4 of those terms. You guys can hit pause. Okay. So the magic number that's going to go into all of these is 8. So we're going to go through and divide every single term by 8. So that will leave us, oh, sorry, bigger than 8. I think it's actually 6. Sorry about that, guys. It's going to be 6. So 240 divided by 6 is going to give me 40 m squared n plus 384 divided by 6. No, it's bigger than 6. I'm just a mess today. Oh, no, that's it. Plus 40 m squared n plus 64 m squared minus 5 bmn minus 6 bm, or 8 bm. Sorry about that. So GCF was a 6. I divided all the terms by 6. I'm going to put a box around the GCF and draw an arrow down so I remember to bring it down at the end of my problem, but I'm going to kind of forget about it for a moment and do grouping method with these 3 terms, or 4 terms. You guys go ahead and pause the video, try a grouping method with those 4 terms, and then check your work. Splitting this in half, I'm looking for the GCF amongst those 2 terms. We're going to factor out an 8m squared. That will leave me with 5n plus 8. On the other side, we're going to factor out a negative bm. Okay, there's not a number that goes into 5 and 8, but we'll factor out the negative and a b and an m factor. And that will leave us with 5n plus 8. So I will get 5n plus 8 times 8m squared minus bm. And I'm going to bring down my 6 here. Now this is technically not done because in the very beginning of the problem, I just noticed I did not factor out my m. All four of these original terms had an m in common, so I could have factored that out. But you can still save yourself at the end, so I'm kind of glad I made this mistake here. And I'm going to factor out the m now from this second factor here. Take an m out there and an m out there. So I will have 6m times 5n plus 8 times 8m minus b. So I removed a b factor from that last factor pair. And that will be your final answer. So if at any point in time you forget to do a GCF in the beginning, you can always take out the GCF at the end of the problem, as long as it's taken out at some point. We're going to switch gears a little bit and move towards polynomials that have 3 terms. So these examples, we're still factoring, but these are quadratic-like trinomials, so 3 terms. So when you factored quadratics that had 3 terms, we most often did guess and check. So that's what you're going to be doing in these examples as well. You're going to be guessing and checking. I just want to list some forms that fall into this category. So think of the general form of a quadratic in standard form, ax squared plus bx plus c. If I continue that power with other polynomials, it's only going to work as long as the degree is even. So something like ax to the 4th, and then this would have to be, the middle term exponent has to be half of the first term. So if this was x squared in the first one, the middle term was a x to the 1st power. So if we have x to the 4th, the middle term needs to be an x squared plus c. If this relationship doesn't happen, you can't use guessing and checking to figure out what it factors into. And the last term is always constant. You can keep going with this, ax to the 6th, and then it would be bx to what power? And yes, that's 3, plus c. I'll do one more, and then I think you guys get the idea. Ax to the 8th plus bx to the 4th plus c. So as long as it falls into one of these, either right away or maybe after you take out a GCF, we can go through and guess and check it. So we'll do just a couple of those. So x to the 4th plus 4x squared minus 21. Because our a value is a 1 here, we will find factors of c that add to the b, and that winning pair is going to be 7 and 3. So I will end up with same sort of thing we did with quadratics, but to get an x to the 4th, it's got to be x squared, which is why that middle b term is an x squared term when you combine like terms after foiling. And then to get a positive 4, I need plus 7 and minus 3. Just double check to make sure none of those factors are a difference of 2 squares, and none of them are, so it's done. Okay, I'm going to have you guys try this one on your own. Okay, so pause the video and go ahead and work that through that one and check your work with mine. So I'm going to set up my binomial. The only factors of 2 are 2 and 1, so it's going to be 2x to the 4th and 1x to the 4th. And then you have to work through and find factors of 20. So it could be 1 and 20, 2 and 10, 4 and 5. So you have to figure out which ones that when I check my outer and my inner will give me a negative 3x. So to get that, we're going to put, let's see here, a 4 here. Okay, so 2 times 4 when I check my outer will give me 8. And then if I put a 5 here, 8 and 5 can give me 3. So in order to get a negative 3, I want a negative 8 plus 5. All right. Before I keep factoring further, because I'm going to be able to on this one, which will lead into the last type of example, is I just want to 100% confirm here, ax to the 4th, then my inner plus negative 8x to the 4th plus 5x to the 4th equals negative 3x to the 4th, which does match up. Now the reason this can go further is this last factor right here is a difference of 2 squares. Okay, so the exponent of 4 still falls into a D2S category. So we're going to factor that last one further, 2x to the fourth plus 5, and then that will factor into x squared plus 2 and x squared minus 2. And that will be the final answer. So building off of that, let's talk about the final example in this video that you guys are going to practice, which are quadratic-like binomials. So these fall into the difference of perfect square or two squares category. So when you did quadratics, like you had a perfect square, 1, and then it was x squared minus another perfect square. So I'm using p to represent a perfect square term. So if I continue, I could have a perfect square and then x to the fourth minus a perfect square. I could have a perfect square, x to the sixth minus a perfect square, etc. This second term here with the second perfect square, that could also have another even exponent, like an x to the fourth power, x to the eighth power. But keep in mind, if x is in the first term and x is in the second term, you're going to end up factoring that out as a GCF first. But you also could have something like with a y squared at the end. That's still doable. So let's try a few of these. So if I gave you 81 x to the fourth minus 16, the reason why it's considered a difference of two squares is I could technically rewrite this as 81 x squared squared. So this x squared is a perfect square because I could rewrite x to the fourth as x squared to the second power. So it's still being raised to a second power. But all you really need to apply is the same shortcut that you did prior and square root each of these. So square root of 81 is 9. If you square root the x to the fourth, like think about square rooting this term right there, those cancel and it leaves you with an x squared. So you have 9x squared for both, and then plus 4 minus 4. Always double check before you say you're done, because this right here is another difference of two squares. That can go further. Make sure you don't attempt to try to factor a sum of two squares. Those are not factorable. And we'll get 3x plus 2 and 3x minus 2. And have you guys try this next one on your own. So after I write it, you guys can pause. 25x to the 8th minus 9. Let's go through on that one, then unpause to check your work. So again, I could technically rewrite this as 25x to the 4th power squared minus 9, because 4 times 2 would give me that exponent of 8. So I'm just rewriting that x as a power of 2 to show that it is a perfect square. So if I set up my factors, we're going to get 5x to the 4th plus 3 and 5x to the 4th minus 3, neither of which are a perfect square. And last example, I'm going to give you guys 49x to the 6th minus y to the 4th. Let's go ahead and pause and check your work. I could rewrite this as 49x cubed to the 2nd power, 3 times 2 is 6, minus y squared to the 2nd power. So just rewriting them as powers of 2 to show they're perfect squares. And if I set up my two factors, I'm going to get 7x cubed, because when you square root this term right here, those cancel, and you'll be left with an x cubed for both. And then plus y squared minus y squared. And that is it. So that's a summary of what you needed to watch today. So we reviewed the grouping method for polynomials that have 4 terms. Polynomials that have 3 terms, you're going to guess and check. But remember, the middle term's exponent needs to be half of what the degree is in order for it to work, and the last term needs to be a constant term. And then we reviewed applying the difference of two squares strategies to other types of polynomials. So tomorrow we'll do some practice on this, and we'll learn a third or a new method of factoring a polynomial that we haven't learned yet. All right, see you guys tomorrow. Enjoy the rest of your night.